All right, let's look at compound and continuous compound interest. The first part of this is actually a review from 1324. So hopefully you already remember this, but if not, a lot of this you can go back and review in section 3.2, where you talked about simple interest versus compound interest. Where simple interest, you get charged all at once. Compound interest is like your credit card. Every month they add interest on interest. So one form of this compound interest formula looks like this, where P is the principal, the amount invested or borrowed. R is the interest rate. You change it to a decimal. T is compounding time, and it needs to be in years. And then A gives you the amount of the investment or the loan after interest is applied. So let's look at an example. You invested $1,000 at a bank that pays 3% interest compounding quarterly. So the principal, how much is invested, is $1,000. The rate, I changed to a decimal. Quarterly, so if you think about this, January, February, March, April, that's one quarter. May, June, July, August, that's another quarter. September, October, November, December. So there's 3 out of 12 months. And if you multiply all this, this is the amount of the investment. This is just after the first quarter. So interest earned would be your $1,000 taken away from this $1,007.50. So you got $7.50. What happens is this amount becomes the principal for the next quarter. So we take this $1,007.50 and that becomes our principal. We get our new amount after the second quarter. And as you can see, interest has changed a little bit. And then this becomes the amount for the next quarter. So what's happening, and you don't see it huge because our interest rate is so small, 3%, and plus the $1,000 is so small, but this is actually going up, and that's what we talk about, interest on interest. So we continue to do this. This becomes for the new period until we get through the investment at the end of the year, that is the fourth quarter. So the first year with interest earned this quarter. And so we can see this changed a little bit. Where simple interest tacks on interest at the beginning of the loan once. So in other words, your time is just 1 because it gets tacked on right away. And as you can see, there's a little bit of difference between simple interest and compound interest. If it was a large loan or investment and a very high rate, then you would see a bigger difference here. Where the biggest difference between compound and simple interest, compound interest is great if you're investing, but it's horrible if you're charging, because this is what happens to people that start charging on their credit cards is it gets out of hand because they're paying interest on interest. All right, if the interest rate is typically given to you annually, I mean, watch car commercials. It'll say APR, so your annual percentage rate. And to find the rate per compounding period, what you can do is divide out the number of compounding periods per year. We'll call this M. And so we let this I equal the rate over M. For 1 year, the simple interest on interest computes the formula a first time, a second time, a third time, and so on. Well, what we could do is we could raise it to an exponent, the number of compounding periods, and we can now rewrite this formula as the rate over the number of compounding periods. This N equals the compounding periods times time. So you might see it written either way. I kind of like this second way because it makes it easy to break this down into pieces. A is still the amount at the end of the loan. P is still the principal. Some call it present value, the amount invested or borrowed. R is still your interest rate. T is still your time in years. But now this M is the number of times it's compounded a year. So something like a credit card, typically you pay interest every month, and thus this value would be 12 if it's compounded every month. Look at an example. Our same one, our $1,000, our interest rate's 3% for 1 year. Number of compounding periods a year, quarterly, so 4 times a year. I plug everything in and I can see I don't have to go through that first quarter, second quarter, third quarter. Sometimes you like to do that because you might want to know where you are after the first or second quarter. But what this gives you is at the end of the entire year. And so it just makes it easier. Let's say I want to do 3 years. I don't have to continue to go through this in steps. I can see at the end of 3 years what I would have. All right, we can have various compounding periods just to see how to plug this into the formula. Annually, my M is 1. Semi-annually, 2, twice a year. Quarterly, 4. And monthly, 12. So what's the big deal? Well, the big deal is you really need to understand interest so you don't get yourself in trouble like a lot of people do. I mean, here's just an example. You go to Best Buy, you buy a brand new television. They have pretty high interest. In fact, 19% is not horribly bad. I've seen people that pay 29%. And if you did not pay a single payment at the end of the first year, look how much you would owe. And this is where people get themselves in trouble. Even paying the minimum is this starts to go up higher than what you even spent the money on. And so you just have to be careful with things like this, so that you really understand how the interest works. Let's look at what happens when your compounding periods times your year. So remember, that's this M times N. When it grows very, very large, watch what happens here. That this value, okay, our rate is getting really close to a number, which is E. And that's where this E comes from, is by taking the limit. Is we can see if you use continuous compound interest, which means interest is being charged every day, every minute, every second, every millisecond. In other words, continuously. And that's this formula, where continuous compound interest, the A is still the amount at the end of your loan or invested. P is still the principal, the amount borrowed or invested. R is still the rate, T is still the time. The difference here is you have this E, which remember E is just a number, but most of your scientific calculators will have, and you want to use it so you get your decimal places. So it says an investment of $1,000 earns interest at an annual rate of 4% compounded continuously. Find the instantaneous rate of change of the amount after 2 years. Find the instantaneous rate of change of the amount in the account at the time the amount is equal to $2,000. All right, well, let's see. The instantaneous rate of change of the amount. Well, the instantaneous rate of change, if the first thing I do is I set up my continuous, so my P, which is principal, 1,000, E raised to the RT. Instantaneous rate of change says find the derivative. The 1,000 is just a constant that goes out front. E raised to any power, the derivative is E raised to that power times the derivative of the power. That's the chain rule piece. So that's why you see the 0.04, because that's the derivative of the exponent. And as you see, I multiply that out to get my value. So the instantaneous rate of change of the amount after 2 years, I found the derivative and I simply plug in 2. So this tells me after 2 years, the rate, okay, because remember, derivative is the rate that this is changing. Find the instantaneous rate of change of the amount in the account at the time the amount is equal to 2,000. Well, if I go back and I look at this piece, This 1,000 times this e to the 0.04t, so I just move these around in order. This gives me back my a to the t, right? That's my original a to the t. So what this says, to find this, all I have to do is take the instantaneous rate of change is going to always be equal to the amount. So there's the amount times the rate. So I simply take the 2,000, multiply it by the 0.04, and I get the instantaneous rate of change when the amount is equal to 2,000 is $80 per year.